Unit 6, Lesson 2, Video 2. So let's focus on our first area here, experimental probability. Now again, notice that we are still dealing with probability. So you have to decide if a question is dealing with probability and then go from there and say, is it experimental or not? We've mentioned the law of large numbers, and that goes along with an experiment because the more you do an experiment, the more trials you have, the more it gets to its theoretical probability. Now, in the definition here, the probability that a certain outcome will occur as determined through an experiment. So here we have an example 1, an experiment that is run. And over time, you'll notice that even though the probability, that's written right here, changes with each trial or experiment, it does eventually start to settle on a certain value. That's the law of large numbers talking. So over time, you should get closer and closer to that theoretical probability. But again, we're caring about looking at this problem and saying, is it experimental or theoretical? And this is indeed experimental. The solution to this would be where it's kind of, what is the probability of this scenario? It would be where it's starting to hover around. So in this case, it'd be 0.4, or in other words, 40%. Okay. Now, again, experimental probability needs you to do an experiment or to collect data. In example 2 here, you're doing a survey basically of 100 people. And from that survey, you're getting information. They say that 12 people say they attend movies 2 or 3 times a month. The remainder, which would be 88, attend movies once a month. So again, what kind of question? How do we tell what it is? Well, it says in the end, what's the probability? So it's a probability question. And then you say, well, how did I get my information? And it was a survey, basically. So that makes it experimental. You can also flip a coin 100 times, and the result of that experiment gives you the probability of heads. We know that probability of heads is 50-50, but the experiment might say different. And that's okay, that's an experiment. But you have to look at that experiment to get your experimental probability. And over time, again, the experimental probability should come out to be your theoretical. That's the law of large numbers theory. And the last one, very common, you have a batting average of .223, which we know is 22.3%, but statistical people in baseball love to use 3 decimals. So we have .223, or they say they're batting .223, which is actually okay. But the question here says, what's the probability that she will get a hit? I should have a parenthesis here, sorry. Well, that probability is not theory, because she has a history. And you look at her history and it says that she bats around .223. So the probability that she would get a hit is that same thing. And again, that's a living, changing probability because of the experiment of her playing. So again, notice how you get your data to help you decide if it's experimental or theoretical. And this ends Unit 6, Lesson 2, Video 2.